Every 20 seconds, a new fire breaks out somewhere in America, and the typical house can burn down in under 20 minutes. Since the invention of the modern fire extinguisher, engineers have been trying to find a better way to tame the flame.
This is the first line of defense, the portable fire extinguisher. It all begins here with a sheet of carbon steel.
Every extinguisher starts off a carbon steel blank. It's about an 1/8 inch in thickness.
It's like a big sheet of paper almost, only it's steel.
Big rectangular sheet of steel, exactly right.
Razor-sharp blades cut the sheets into 20-inch squares. Then a roller actually bends the steel to create a tubular shape. This tube will become the first of the 3 key parts of any fire extinguisher, the tank. The other key components, a source of pressure and a fire-suppressing agent, will be added later in the manufacturing process. Now that the steel is bent into shape, it's going to be welded shut.
What that seamless welder is doing is grabbing that shell, overlapping the 2 edges, and welding the shell together.
Why are you using steel?
The steel is required because of the environment that this extinguisher is put into. These are going into high-hazard, high-risk environments like chemical, petrochemical, mining. Durability is everything to that industrial firefighter.
Once the tubes have been sealed, they go into this clay oven, which heats the top of the steel tube to over 2,500 degrees. Then this device, called a hot spinning lathe, spins the cylinder at over 30 miles per hour, while the torch keeps the metal burning hot. This manipulates the molten steel into a dome.
As you can see, the operator, with the levers and controls, he's forming the head of that cylinder.
Finally, this giant press molds the heated metal into its finished and perfectly rounded shape.
And the next step is what we call this piercing press here. And we're actually going to be piercing the 2 holes that you see here.
In and the out.
The in and the out, exactly.
These openings will accommodate the internal gas tube and hose. To complete the tank, machinists weld the bottom and top onto the tube. After a quick test for leaks, the shells are sanded, washed, and given their signature feature, their color.
Ah, it's the paint shop, you bet. This is go ahead.
Oh.
This is where we add the signature color red, the fire engine red. And as you can see, we have the 20-pound shells going down the conveyor line to be painted through the automatic paint line.
So this isn't paint like we think about liquid, runny paint. This is like little particles that are dry.
Exactly. This is a durable polyester-based paint. And basically what we're doing here now is we're electrostatically applying a charge, a positive and negative charge to the paint and to the shell.
Okay.
Basically like a magnet would stick to steel, the powder paint is going to stick to that shell, and it's going to go through an oven where it gets baked for about a half hour at 400, 450 degrees.
This special powder coating resists cracking, chipping, and corrosion. It's just another way engineers ensure that this extinguisher will survive the toughest fires.
Why red? I mean, why are fire trucks painted red? What is it with red?
Visibility.
Okay.
Easy on the eye, easy to see.
Except in this room.
Except in this room. You'd probably lose it. It'd be camouflaged into the wall.
Now it's time for workers to put the rest of the extinguisher together here in the fabrication room.
Basically, what we're going to do is we're going to take this shell, this red line shell, and we're going to send it down the last 4 or 5 stages and pack it out and show you how we take it and deliver it to a customer.
The first step, attach an adhesive label to the unit.
Our labels tell us how to operate the extinguisher. They also tell us proper maintenance and service.
Next, workers secure the gas tube, handle, and hose. And finally, this extinguisher's key feature.
Our next step here is installing the cartridge. This is our heart of the extinguisher again. That contains the pressure source as the expellant gas for the unit.
The side-mounted cartridge contains either carbon dioxide or nitrogen. By pushing this button, the gas escapes into the tank, applying pressure to the fire suppressant material. The pressure forces the material up into the hose, where it's released by opening the nozzle. A single 20-pound redline extinguisher will discharge all of its contents in no less than 13 seconds. Unlike other extinguishers that must be pressurized at the factory, redline extinguishers can be refilled and recharged by the user over and over again.
This here happens to be a recycled cartridge. That's one of the beauties of the cartridge-operated extinguisher.
Is this how old it is?
That's how old it is. Born back on 1989, or back in June of 1989.
The installation of the cartridge means this extinguisher is almost ready for use. But it still needs one more thing, the stuff that actually puts the fire out. Fire consists of 4 components: oxygen, heat, a source of fuel, and a chemical reaction. This is known as the fire tetrahedron. Knock out any one of the 4 legs, and the fire goes out. The introduction of these more advanced dry chemical fire suppressants revolutionized the modern fire extinguisher.
Well, what does it actually do? I mean, it's just a powder. How is it actually putting out a fire?
Well, it actually puts fire out by interrupting the chemical chain reaction or stopping the chemical process of fire.
The dry chemicals stop that chain reaction by coating the fuel with a thin layer of fire retardant powder. This separates the fuel from the oxygen it needs to burn. Once they load dry chemical, workers seal the extinguisher and add the cartridge guard.
Look, it's finished fire extinguishers.
After a few tips on how to operate this 20-pound redline extinguisher, Marshall's ready to tackle this.
That's a big fire, Marshall.
That is a big fire.
How big? It's 150 square feet of burning gasoline. And Marshall can feel the heat, even through his protective gear.
Holy, that's hot. How hot is this?
Approximately 1,200 degrees Fahrenheit.
That's like the space shuttle re-entering the atmosphere or something, isn't it?
Darn close.
He'll have to work quickly because there's only so much fire suppressant in the tank.
Are you ready? Remember, you have 13 seconds to put this fire out. That away, sweep! Yeah! Yeah! Oh! Lighter, yes! Oh! I thought you had it, Marshall.
That was tough. But Ansell's firefighters decide to give Marshall a second chance with something a little less challenging. Consider it the kiddie pool.
This is a little smaller.
Yes, this is a 40 square foot fuel and depth fire. The one we fought was 150.
Okay.
This unit is rated for this size fire, a 40 square foot. So actuate your unit, pressurize your unit. Good job. Now, you want to stand upwind. See how the wind is blowing that way? So we want to stand over here, half the effective range of the unit. So you want to stand back 12 feet. There you go. There you go. Push her back. Good job.
That was
Was that fun?
surprising. That's how
It's
that was.
amazing.